In the known universe, there are approximately 2 billion to 2 trillion galaxies, each containing a multitude of stars and planetary systems. Among them, our galaxy, the Milky Way, harbors 100 billion or 10,000 crore stars like our Sun. In this cosmic dance, our Sun is accompanied by 8 planets, various moons and smaller celestial bodies all orbiting around it. Within this cosmic ensemble, Earth is our home, wasting the perfect condition for life. The air we breathe, the water we drink, and all the essential minerals are evidently available, making life possible. As we sit the sun corner of the earth watching this video, we marvel at the wonder of our existence. Among the countless celestial bodies, the question that has always intrigued our mind is whether Earth is the only planet in this infinite universe where life exists. Are there planets similar to the Earth orbiting stars in their own solar system beyond our solar neighborhood? How do scientists explore these exoplanets, and what methods do they employ to uncover their mysteries? Let's delve into these questions. The search for knowledge about planets beyond our solar system, also known as exoplanets, was a challenge for centuries. Scientists and philosophers wonder about celestial bodies revolving around stars other than those in our solar system. However, due to the vast distance and the intense brightness of stars, it was nearly impossible to detect planets around them. The breakthrough came in 1918 when the first scientific discovery of the exoplanet orbiting the pulsar PSR B 1257+12 was made. Subsequently, in 1992, the Arecibo Observatory confirmed the existence of several local exoplanets orbiting their pulsar. These planets located outside our solar system were termed exoplanets. In 1995, scientists discovered the exoplanet orbiting the Sun-like stars, Pegasi 51. This exoplanet named Pegasi 51b completed one orbit around its star in just 4 days, meaning its experience 1 year is only 4 Earth days. Before delving into the species of exoplanets, it's crucial to understand the challenge scientists face in discovering them. The primary hurdles are the immense distance from the Earth and the overwhelming brightness of stars. The nearest star to the Earth is our Sun, and it is approximately 150 million kilometers away. The second closest star, Proxima Centauri, is over 4.24 light years away, or 9.44 trillion kilometers. The brightness of these stars is so intense that it makes it difficult to observe anything else in their vicinity. To illustrate, if we try to spot a firefly twinkling around cricket stadium lights from a considerable distance, it is comparable to attempting to observe an exoplanet from Earth. Hence, until 30 years ago, know about these exoplanets, as their discovery was a monumental challenge. The journey to unveil the secrets of these distant worlds continues, opening new chapter in our exploration of the cosmos. What, in the famous scientist Stephen Hawking's words, humanity can transcend its ephemeral limits with the help of both the mind and machines. Following his insight, some scientists embarked on a new journey of exoplanets, diving into the captivating light emanating from these beautiful stars. Consequently, a revolutionary method for the exoplanet discovery emerged, known as Doppler spectroscopy or radial velocity method. Doppler spectroscopy or radial velocity method challenges the common misconception that the Sun is stationary and all planets orbit around it. The reality is that our sun, influenced by the gravitational effects of massive planets in our solar systems, also orbits around a common center, albeit in a tiny orbit. This motion is challenging to precise due to the vast distance involved. Through observations conducted at the Arecibo Observatory, the movement of our sun influenced by the gravitational pull of Jupiter was measured. The sun at the speed of 13 meters per second due to the Jupiter's gravity and 9 centimeters per second due to the Earth's gravity is in orbit within a small region around the center point. Similarly, thousands of light years away, the stars in distant galaxies experience fluctuations in their motions caused by a gravitational attraction of their massive planets. This phenomenon is known as radial velocity, where stars also exhibit motion due to their planets. This radial velocity is easily detected through the Doppler effect. Understanding the Doppler effect might require delving into intermediate level subject involving formulas and mathematical calculations. However, to put it simply, it allows us to determine the radial velocity and consequently the frequency of any star lights. Let's illustrate this with an example. Often, when a train is crossing platform, the sound of its horn suddenly changes. This occurs because as the train approaches, the frequency of the horn increases, and as it moves away, the frequency decreases. Similarly, in the search of exoplanets, astronomers use Doppler spectroscopy to observe shift in the spectral line or pattern of light from stars related to the order of colors. The Doppler effect enables scientists to discern the radial velocity of stars and consequently the associated with their motion. By applying this method, astronomers have successfully discovered 1075 exoplanets to date. The major limitations of this method was that could only detect planets larger than or equal to Jupiter orbiting very close to their stars. This technique was not effective to finding Earth-like rocky planets in the habitable zone around their stars. To overcome this, scientists developing a new technique known as transit photometry. Transit photometry method. Transit photometry involves observing the variation of the brightness of a star in their color sequence. Numerous observatories use their method to gather information about planets, focusing on the rocky planets in the habitable zones of their stars. Unlike Doppler spectroscopy, which only reveals the minimum mass of the planets, transit photometry provides valuable insights into the characteristics of planets similar to Earth. Transit photometry method. When a planet orbits its star and comes between us and the star, it either diminishes some of the star's light or the planet obstructs the portion of the star light. We can observe the reduction or dip through a graph. Within our solar system, observatories on Earth using the transit method have to detect instances where Venus and Mercury, while passing in front of Sun, cause repeated dimming in the Sun's brightness. Earth-sized exoplanet passing in front of Sun-like star creating a minuscule dip in brightness as low as 0.008%. For instance, the massive exoplanet named HD209458b reduced its star's brightness by 1.7%. In 1999, scientists from the Geneva Observatory, Harvard Smithsonian Center for Astrophysics, and the California and Carnegie Planet Search Team used radial velocity method to discover the first extrasolar planet named HD209458b around a star. Shortly after, team led by David Charvenue and Gregory W. Henry used transit photometry to identify the name this planet is HD HD209458b. This method estimates a planet size and mass and calculating how long it takes to complete an orbit and the amount of starlight it blocks, revealing whether the planet is rocky like Earth-like or gas giant like Jupiter. The popularity of this planet soared when signs of water vapor in its atmosphere were discovered. Transit photometry enables astronomers to calculate the volume and density of exoplanets while analyzing how much starlight passes through its atmosphere. This method also reveals the presence of various elements and the temperature in the exoplanet atmosphere as it transits its star. However, Earth's atmospheric gases and dust pose challenge the accurately observing exoplanets with different instruments. To overcome this, NASA launched the Kepler Space Telescope in 2009, placing it outside Earth's atmosphere in heliocentric orbit. Kepler scanned a large number of stars in the sky using transit photometry to detect Earth-like planets. This mission marked a significant leap in our ability to explore the understand exoplanets beyond our solar system. On December 5, 2011, the Kepler mission team shared exciting news. The Kepler telescope had discovered 2,325 exoplanets, including 207 Earth-size, 680 super-Earths, 1,181 Neptune-like, and 2,000 Jupiter-sized exoplanets. Remarkably, 55 of these planets were even larger than Jupiter planet. Fast forward of June 2013, and the Kepler team revealed that tally had risen to 3,278 exoplanets. Among them were some smaller than Earth-like Kepler-62b, a Mars-sized exoplanets. In an ambitious move, the transitioning exoplanet survey satellite TESS launched on April 2018 with the goal of scanning the area and 400 times larger than the Kepler covered. TESS station in Earth orbit employed transit photometry for 2 years to identify exoplanets, especially those resembling Earth in size and radiance. By November 15, 2023, TESS had identified 6,977 exoplanets, with 400 of them already confirmed. Notably, by March 21, 2022, confirmation had been received for the discovery of the 5,000th exoplanet beyond our solar system. On January 11, 2023, NASA scientists using the James Webb Space Telescope located an exoplanet named LHS 475b nearly 40.7 light years away in the Octans constellation. This rocky planet orbits its star in just 2 days, making its year incredibly short. LHS 475b, with a mass equivalent to 91.4% of Earth, is tightly locked to its star, meaning one side always has daylight while the other remains in perpetual darkness. A fascinating characteristic known as a tidal locking, Y-side direct imaging exoplanets having also been discovered using gravitational microlensing and astrometry methods. Earth-like exoplanets. Let us delve into the exoplanet closest to Earth in the neighboring stellar systems. One such planet considered the most favorable for life akin to Earth is Proxima Centauri b. This planet, discovered in 2016 by NASA scientists, has a mass 1.27 times that of Earth. Orbiting its nearly star in the habitable zone, scientists have hoped to Proxima Centauri b might harbor water in a liquid state. Moving to Kepler 452b. This planet found by the Kepler telescope orbiting a sun-like star approximately 1400 light-years away. Kepler 452b is 1.6 times larger than Earth and reside in its star's habitable zone, sparking optimism about its potential Earth-like environment. Kepler 1649c Exoplanet, discovered with the help of Kepler telescope, is a small red dwarf orbiting planet located 300 light-years away from the Earth. Slightly larger than the Earth, with a comparable temperature, it absorbs 75% of its energy from its star. Another intriguing discovery is K2-18b, situated 124 light-years away from Earth in habitable zone of a red dwarf star named K2-18. It's about 8 times the mass of Earth and complete an orbit in just 33 days. In 2019, signs of water vapor were detected in its atmosphere, sparking significant interest among scientists. In addition of these, numerous Earth-like exoplanets have been discovered, such as Trappiest F1, Teegarden, gliese 667c, Kepler 22v, Kepler 69c, Kepler 62f, Kepler 186f, and many more. As of November 2013, scientists estimate that there could be around 200 billion Earth-like exoplanets in our Milky Way galaxy alone. This suggests that the vastness of the universe, there might be 11 billion potentially habitable planets. So friends, that's all for this video. For more interesting content, visit our channel. Until next time, goodbye and Jai Hind.